Hello Python programmers. In this video we will look at importing some data, manipulating it, mostly using our old friend list comprehension, and then experimenting with a few plotting styles. I provided this notebook for you. You can follow along with me. I also provided the data file, which I got from the United States government census website. And it's a little bit messy, which for me is good because it gets us something to talk about. I have my import statements at the top. I'll be using the CSV library to consume a file, and I'll be using the matplotlib library to plot the file. I'll execute that cell before I always forget. In the next cell, we're using that wonderful with syntax. And that with syntax opens the file, prepares it for us to read, and gives us a handle on that file. And we just chose to call that handle file. We can call it whatever we like. We can call it Fred. Doesn't matter. Except we better change the name everywhere, because when we called it Fred in the with statement and called it file in the CSV reader statement, we created a problem for ourselves. So I'll just change this to Fred. Now let's try it. There we go. This cell doesn't generate any output, but it did read the file line by line and then create a list, and each element of the list is one row from the file. Before we go any farther, let's look at the file. And we'll start by looking at it in Excel. Why not? It has a header, okay, which we're going to want to get rid of. And it has what appear to be states of the United States from Alabama to Wyoming. There are 52 rows in here. One of those is the header row, and the other one would probably be District of Columbia, so that's a total of 51 states plus the DC. Also notice that the states have a dot in front of them. And when I scraped this off the website or downloaded it, I honestly don't remember. There was a dot there. I didn't put it in. So it was provided to me in this form, and I thought I would leave it there and take it out as an exercise. I could just as easily go into Excel and edit this file, but that's not a very process-friendly thing to do, is manually edit a file like that. Also notice the census numeric values have commas in them, which is great for humans to read, but not so terrific for Python. So we are going to have to remove the dots and remove the commas. All right, that's understandable. We can do that. But let's look at this file in CSV format. Once again, I will use my Notepad++. Looks fine. Now it looks more like a CSV file. There's my comma between the two columns. That's how Excel decided to parse. But looking ahead a little bit, notice that there are commas inside of quotes, and we don't want to split on those. So there's a problem presented there too. But we can overcome all these problems, don't worry. Looks reasonable. I can live with it. The next cell simply does a little bit of printing, and I can say that what I got when I read that CSV file is a list of lists, and each element in that list of lists has one thing in it, which is a string with a state followed by a comma followed by a double quote, and it's just a big mess. Focus on Let's take out this first print statement. It's just cluttering us up too much. That's the first column. Let's print the first row. Let's print the second row. We don't really care about the first row anymore. Okay, so focus on that. That's what Python thinks we have. And there's 52 of those. I need to split this up on the first comma. I need to stop splitting at that point. I don't want to split on the second comma because that's the middle of that population number. It's not a splitting delimiter. It's just a readability thing for a numeric value. And then I've got double quotes in here that are going to need to go away. So I got a little bit of work to do. Easy enough it is to slice and get rid of the header. So I store my sliced data set into a reference called clean data. So now clean data has 51 rows in it, right? 51, because I got rid of the 52nd. I might be counting that wrong. I have a feeling that I'm not. Is it 53? 52. Okay, I was right. So when I get rid of one, I'm down to 51. Good. I thought Puerto Rico was in there for a moment. I had a moment of panic. So now I'm down to 51. The next thing I need to do is split it into two strings, and that's easy enough to do, except I realize that there are multiple commas in there that I don't want to split on. I only want to split on the comma between the state and the population total. It's all one big string. That comma is there for a reason, to separate the first column from the second column. But then I need to stop splitting. And Python lets me do that. It has this amazing second argument in the split function. The first argument says split on a comma. The second argument says don't split after the first comma. Just split on the first comma. Therefore, I'm not going to split on the comma right in the middle of the population number. I'm only going to split on the comma between the two columns. And that's terrific. The next thing I do is try to get rid of that leading period. And the way to do that is with a slice. Again, I still want to come out of this with another list of lists, but I still want that first element in each sublist to not have its leading character anymore. So I do a slice right there. For every element in my list called clean data, I take the first element of that sublist and I slice off the first character, and then I take the entire second element of that sublist and I use those two things to build a new list. And I do that over and over and over for everything in the clean data list. The next thing I do is eliminate those double quotes. Those double quotes came along for the ride. I have what I know to be numeric values. I don't need to put quotes around them. I do another slice. In this case, for every list in the clean data list, I want the entire first element, which is the state name, and I want the second element except for the first and last characters. So I slice off the first character, slice off the last character, and take what's in the middle. That gives me the numeric value. It's still got commas in it, but it's no longer enclosed in double quotes anymore. And we could probably clarify this by saying double quotes around them. And again, those came from the original data. Okay, that was not an artifact of them being imported by CSV. The Python CSV library did not put those double quotes in there. They're there originally. The next thing I want to do is get rid of those commas. Now I know that the only commas left are the ones in those numeric values. There's nothing left to split on because I already split. Therefore, I'm just replacing all the commas with nothing. finally, once the commas are gone, I can convert those values to integers. So I'm building another list of lists. The first element in each sublist is the state name. The second element in each sublist is that value that I know is a number, but is being stored as a string converted to an integer. Finally, I'm so proud of myself, I print the whole thing. This will just be a big mess. So let me run this cell that does all these monstrous list comprehension processes. I guess it ran. That was very quick. Print the thing out. There it is. Each sublist now consists of two elements. The first is a string, the state name. The second is the population of that state as an integer. And I could do math on those integers if I wanted to. I could take the average, the max, the min, the sum, whatever was necessary, because now they're numeric data types. Okay. All right, we're ready to plot something. We've cleaned it up. I'm going to do a line plot. Why not? I'm not going to go through the step of converting into an X and a Y array. I'm just going to use X and Y right out of my list of lists. So what we're seeing here then is list comprehension twice, and each of the results becomes half of a data point. And I'm asking for a dashed line. Let's see what I get. It won't look very good. There it is. This isn't a linear data set. There's no connection between Arkansas and Alabama population-wise, especially since they're just in alphabetical order. So this type of plot has no value at all. It's purely to show off that I can do list comprehension and extract values and pass them directly into the plot. So that's worthless. I'll delete that output. Don't need that anymore. Let's try a bar chart. For the bar chart, I'm going to create a figure so I have a place to plot. I'm going to add a subplot that consumes the entire figure, a 1-by-1 array of subplots. And then I'll do a bar chart. Is a bar chart more conducive to representing this discrete data? Let's find out. And there it is. It's not bad. If I had some decent labels on the tick marks along the x-axis, I might get some value out of this. But the tick marks are horizontal, and they just overwrite each other. You can see over at the far left-hand bottom corner of the plot the first three letters of Alabama, but then all the other tick mark labels just turned into a big blobby mess. The bar chart function made an effort, and that's the best it could do. But what if I rotate those labels? That's pretty easy. I'll create a new figure. I'm going to do an add axis function. And that's going to resize the figure a little bit just to make it fit. This took some experimentation. You can play with those numbers if you like, but it took me a little bit of time to get this right. And then I'm going to do another bar chart. The trick here, though, is that I'm going to rotate the ticks. Instead of being horizontal labels on the tick marks, they are going to be vertical labels rotated by 90 degrees. And I've also added a X label and a Y label and a title. You can see that I picked the font size. A lot of experimentation went into this. There's just no way around it. Sometimes you have to work with the fonts to get things to fit. And I can tell you that resizing the figure to get the labels outside of the plot was a headache. So take a shot at tweaking those numbers and see what you get, because this is what I got, and it looked fairly decent, so I left it alone. Let's see what I get. There it is. That's not bad at all. If I had the eyes of an eagle, I could read these state names and start to get some value from this plot. But still, trying to jam 50 states onto a canvas this size just isn't feasible, isn't a reasonable expectation. So what if I just gave up on plotting all 50 and I wanted the top 10 by population? So instead of going alphabetical now, let's take the top 10 in population, and I'm going to do a sort. Now the sort requires me to tell it how to sort. Let me restate that. It requires me to tell it what to sort on. And that's my x sub 1. Okay, that's the population value in that list of lists. And that's what that syntax means. I won't ask you to do that, don't worry. And then I'm saying sort reverse order. That means I get descending values in the sort. We could, of course, print that. I'm only interested in the first 10, therefore I printed a slice of that result. If we run that cell, California has the highest population, the top 10, and coming in at number 10 is North Carolina, which is surprising. I had no idea. Never would have guessed that. But now I've got sorted data and I've only got the top 10. I'm in good shape. This should give me a shot at creating a reasonable plot given the canvas size that I have. Let's give it a try. I can't stand it anymore. I want to know if it works. There we go. Still got a problem though, because the font size of those tick mark labels are just teeny. So is there a way to change the size of a tick mark font on the plot? And you know, your intuition should tell you that there has to be. How about this? Strategic Google searching. Search phrase I used is matplotlib, all one word, change tick label size. If I know a little bit of terminology, I don't even need the word Python here because matplotlib narrows it down, but you could also supply the word Python if you like. And by putting in the word Python, I get a little bit of a Google summary here. And it appears that there is something called font size when I call the set x tick labels. And there's other ways to do it as well using the font size keyword argument. And I happen to have that somewhere here. X ticks rotation equal 90. Can I change it right here? Font size equal. Apparently the font size 70 is going to be what I use for population by state. Let's try that. Let's just try 70 to see how that works. There we go. The keyword argument font size can be used to call the xticks constructor function, just like I used to change the rotation. And now I have something that's reasonable to read. They might even be too big. And I could probably give that to someone to look at and they could get useful information out of it. Although I just noticed, and I hadn't noticed this before, that the X tick labels are really microscopic. I'm afraid to change those because of what might happen to this label on the y-axis. So we'll just try Y. I'm not going to rotate. And let's try font size 50. Cross your fingers. Yeah, that's Not bad, not bad. Population in millions, 35 million. California down to about 9 million for North Carolina. Not a bad choice. So I was able to change the font size of the Y tick marks by using a keyword argument and calling plt.yticks. Remember, PLT refers to our entire plot, the thing that we're drawing. And it's composed of a lot of different components, and we can access those individual components if we know the names of these functions. Hopefully that was useful and interesting. Thank you very much.